Hello. Hello. Can everybody hear me?
Yes.
Yes, we can hear you.
Okay, thank you. Hey, thank you all for joining our first webinar. Actually, from this week, we'll start our online webinar. Actually, maybe twice or three times a week. So every webinar or every course will take a really small topic, and maybe it only takes about 30 minutes in total. And in the end of this training, and we will let you know what is next time and what's the topic of next course. And by the way, this is Ricky from NovaStar North American team. So today we'll start the first training, and our topic for today is loading capacity, which is really common asked question we get from our clients. But the most important thing is for the loading capacity for ALD control systems, we actually calculate it by pixels, because a lot of customers ask about how many cabinets or how large a screen I can drive per port or per controller. So actually, next time if someone asks you about this question, like how many panels I can control per port, you know, okay, he's not the expert of that control system, or at least he's not the expert of a NovaStar control system. So we see here we only focus on pixel level. Like if we give you an example, which is our most basic controller, which is the M control 300, and we know by checking the parameters from the specification, we know the capacity for this controller is 1.3 million pixels. And if you notice that we have two output ports on this card or this box, so it's an easily calculation that we know that each output is 650,000 pixels, so 1.3 million pixels in total. And like the question in the beginning, if someone asks how many panels it can drive per port, and we need to know, because we calculate by pixels, so we need to know how many pixels per panel if someone asks that question. So how do we get the pixel resolution for a panel if you or the customers doesn't know how many pixels wide or how many pixels high? Sometimes they just tell you, and now it's 500 mil by 500 mil panel, and this is the panel we have. And then if we know another information, which is a pixel pinch, if we know the cabinet dimension and pixel pinch, that would be easier for us to calculate out the information we need, like how many pixels wide and how many pixels high we have on this cabinet. So if we check here, the pixel resolution right here, which is the cabinet width times multiplies cabinet height. So if we know the cabinet dimension, and if we divide by the pixel pinch, which should be the pixel resolution. So back at the calculation, see if I can, yeah, by calculation here, we know the dimension is 500 mil, and we know the pixel pinch, the example here is a P3.91. So if we use 500 mil divide by 3.91, then we know it's a 128 pixels, a wide and 128 pixels high resolution. And so by that calculation, we were able to know how many pixels high and how many pixels high we have for this panel. Then once we have the information for per panel, and we can continue like do the calculation and calculate out how many cabinets we can drive or can be loaded by each output port. And another here another example here, for example, if we have a panel which is 192 by 192, and we know that each output port is 650,000 pixels. And if we do the easily calculation, like we use the in total pixel output loading capacity and divide by the pixels quantity for this panel 192 multiply 192, and we know that maximally we can drive 16 panels here. And someone will maybe they will ask, where is the 650,000 pixels coming out of from? Actually, there's a formula we use when we design the system when they do the calculation. And in this formula, so on the top, when we see, because we're transmitting the radio signals, and the connection between the sending card and your screen is standard Type 5 or Cat6 cable, Ethernet cable. So the bandwidth of the Ethernet cable is 1 gigabit per second. And there's another concept called usage rate. So the usage rate is the 100% usage rate is just in the ideal condition. So in the real world and physically, we cannot use 100% of the total bandwidth. So there's a usage rate, and all the bandwidth we can use, actual bandwidth we can use in through this cable, that's the data we're transmitting. So what data we're transmitting? We're transmitting the radio signals. So for the radio signals, there's a concept called frame rate. So the frame rate, like if we transmitting a standard 1920 at 60 hertz radio signal, and the frame rate will be 60 hertz, where sometimes it's 30 hertz or different, or 48 hertz, different hertz. And because we're transmitting radio signal, and for each color, it has its own color base.
Let me see if it'll let you share the screen.
If we are transmitting a 1920 at 1080p and at 60 hertz signal, and through the standard DVI connector, and then we'll have this formula with the value below here.
So let me make sure my audio is set right.
The usage rate here, I just want everybody aware that 93.6%. This is not fixed number. This is an average and safety number we gave it to our clients. Sometimes it could be higher, sometimes it could be lower, according to different quality of the cable or distance of the cable. And because we're transmitting a 60 hertz video signal, so the frame rate is 60 hertz, and then the video signal through DVI, it's 8-bit color. So for each color, we have the all 8 bits. So if we do the calculation, okay, so right now, if we do the calculation according to this formula, we have the total bandwidth. This is 1K, and this is 1 megabit. This is 1 gigabit, and multiply the usage rate, 93.6%. So that's the total bandwidth we have, or as actual bandwidth we can use with the Cat5 or Cat6 cable. And then the loading capacity, or the capacity, the yellow capacity, is the number we're going to calculate out. So to calculate this number out, we have to use that the total bandwidth divide by the frame rate, 60 Hertz, and then divide the color bit depth, 8 plus 8 plus 8, which is 24. And then, so this is the loading capacity, 650,000 pixels. That's loading capacity we are calculate out. And in another word is, for example, in some urgent situation, you're working on site and one of your port is just a little bit over the loading capacity, and you don't have another actual controller to split some panels to the second controller. In that case, by seeing or observing this formula, which means we can drop the frame rate from 60 to 50, then the loading capacity will be increased. So that's all can be calculated by this formula. But another thing is, for 10-bit, if some high-end customer, they want to use like 10-bit or 12-bit color input, once the color bit depth goes up to 10 or 12, the loading capacity will be the half, which is 325,000 pixels. It's a fixed loading capacity when we have 10 or 12-bit color input. The reason is, once it's going up to 10 or 12-bit calculation, the system or the algorithm internal will be considered it's a second byte. So we know 8-bit is 1 byte. So once it go to 10 or 12-bit, it's calculating by 2 byte, which is 16 bits. So that's the reason why the loading capacity will be half. But you don't need to understand actually why it is half. You just need to remember when your input is 10 or 12-bit color, the loading capacity will be half than 0. And we'll also share this presentation, and here is the capacity chart, which is really common used and just for clients' reference. Just by the way, I mentioned, if you have any question, you can leave your question into the chart window, and we'll have someone to record, and then in end of training, we'll answer other questions one by one. Okay, so continue to our training. So right now we know where is the 650,000 pixels coming out. We know that's the capacity for one port. So maybe all of you know we have controllers. Most of the controllers are 4-port controllers. So what about the loading capacity for all of those 4-port controllers? Is it just easily times 4, which is 2.6 million pixels? The answer is definitely no. We're always saying, or if you have ever written our specifications, the loading capacity for those 4-port controllers always says 2.3 million pixels. So the reason why it is 2.3, it is just because it's from the input part. So we know we use the HDMI 1.3 or single link DVI connectors. By checking all supported input resolution with the single link DVI, the maximum resolution, input resolution, it's 1920 by 1200. So the total pixels will be about 2.3 million pixels. So which means 2.3 million pixels, it's the maximum pixel we can get from the source. Then that's why 2.3 million pixels is how many, that's that much pixels we can output with all 4 ports. So here's the confusing part, which is even the total cooling capacity for the whole unit is 2.3 million pixels, but each port it's still 650,000 pixels, which means if we can or map a screen with 650,000 pixels on port 1, 2, and 3, you will not have 650,000 pixels on port 4, which means all 4 ports calculate to in total should be less than 2.3 million pixels. Here, just want everybody to understand that. And also, because we have many controllers, well, we also listed, give it a chart about the link capacity for all of our products. And on the last 2 columns, which is the maximum width and maximum height we supported, it's not that width and height at the same time, which means the height is the capacity divided by width. So for example, if we take the top one, the 300 as an example, we know the loading capacity for that controller is 1.3 million pixels. And then if you want to control or have a 3840 input or 3840 wide screen, then we can only support the maximum 338 pixels high. The last 2 columns is it's just only the single condition when we support the maximum width, and you have to calculate with the formula on the bottom to check how many, if we have a fixed width number or value, you have to calculate how many pixels high you can drive with that width. But you can still go over this this chart after this training. So right now we know that each port's loading capacity, and also we know the total loading capacity for different product. Then actually we want to go through some actual project design. Here we have one example, which is saying we have a screen, an LED screen that the total resolution is 1920 by 1152, and the LED cabinet is 192 by 384. So by calculation, well, it is easy to know we have 10 columns by 3 rows panels, so 30 panels in total. And because the customers only have M Control 660, only that model in stock, and the system is running at 60 Hertz. And so what's a common procedure to configure the screen? Or at least, how do we map the screen? Or because the customer only have that 660, M Control 660, how can we drive or control the screen with a single, or how many 660 we need for this screen? like, okay, so usually we will take about 5 minutes for the customers to do some math by themselves. Let's put on this webinar. We'll just continue with the first solution that which is made by one of our clients. So we know we have 10 by 3, and it's easy to know that. Let's just jump by to this page. It's easy to know by the calculation. So we right now we know $630,000 per port. That's the loading capacity per port, and we know the cabinet size, which is 182 by 384. So if we calculate divide by 182, then divide by 384, then we know maximum we can control 8 panels with the loading capacity per port. Then and also for the whole screen, which is 1920 by 1152, and the pixel in total, which is within 2.3 million pixels. So theoretically, the 660, which is 2.3 pixel load capacity, and each port we can control 8 panels. That's the information we know right now by calculation. And one of our clients engineer, they made this screen connection, and we can see for first port, and on port 1 we have 8 panels, and we have 7 on port 2, another 8 on port 3, another 7 on port 4. So by the calculation, we know 8 panels is good, and the total resolution is within 2.3, and it should be working with this mapping. But when they configure the screen like this and on software and click send to hardware, the software just pop up an alert saying that it's over the loading capacity. Let's see why it is over the loading capacity, and let's get back to the topology of the screen. By calculation, we know the maximum we can connect per port is 8 panels. So right now, 8 panels good is within 650,000 pixels. But actually, in our control system, the algorithm for calculating the loading capacity per port is always a minimum rectangle that covers all the panels on this port. So if you pay attention to the right connection right here. So actually right now for our system, the loading capacity on this port, it's still 9 panels. Which means even the 9th panel is not actually connected, because we're calculating based on a rectangle here. So it's still 9 panels. It's still calculating 9 panels in total. So for the loading capacity. Right. So right now doesn't matter you connect 7 panels or 8 panels or even 9 panels. The loading capacity for those 3 conditions are the same. It's always the loading capacity same as 9 panels here. That's the most important thing of this training. So we're always calculating the loading capacity for every port based on a minimum rectangle that covers all the panels on this port. So if we know we cannot connect like this way, right now, which means if we connect, the 8 panels on port 1 like this, it actually is still calculating the whole 9 panels, which is over the loading capacity. And same thing for port 2. So right now, for port 2, it is calculating still the whole another 9 panels. And actually, even in the third row, it's over calculated. It's calculated twice in this system. So now so right now we know why this is not going to work. But actually we know by the calculation, the whole screen is within 2.3 million pixels. So there should be a way we can make it work with the 660s. And actually, this is the right way, or one of the right way we can configure the wall. And if you check for port 1, we have 8 panels, and another 8 panels on port 2, another 8 panels per 3, and we have 6 panels left, and we put it on port 4. So right now, every port is within 650,000 pixels, and all 4 ports in total, which is the resolution of the whole screen, which is within 2.3 million pixels. So if you click send right now, it will be accessible information, and then we can control the whole screen with 1/660 like that. Okay, that's all for today's training.